Hello friends, in this video we are going to learn about list in Python. A list is a sequence of elements which is mutable, that is modifiable, and which maintains the order in which items are inserted in it. In Python, lists are written with square brackets. So let's flip to Jupyter Notebook and first let's see what are the most important features of a list. So from the definition, we mainly got four features of a list. The first one is it is a sequence of elements. Second one is the elements can be of similar or dissimilar data types. Right? The third thing is a list is mutable. That is, once you create it, after creating it, you can modify the elements inside it. And fourth one is a list maintains the order in which items are inserted in it. Okay, there is another point, and that is list allows duplicate elements inside it. Right? So let's create a list and let's verify all of these points one by one. Fine. So let's create a new cell. And what we just said, we said that when we create a list, we have to enclose the elements inside the list within square brackets, right? So let's create a list and let's give it a name li, and let's create a list of 4 numbers. Let the number be 10, 20, 30 and 40, right? And we enclose them in square bracket. Okay, there is a small typo here. Let's correct it and let's run the cell. So a list has been created, and now if we print the type of the variable li, and run the cell, we can clearly see that this is a list. Fine. So we created a sequence of elements, and all these elements were of the same data type, that is integer. Now what did we say in our second point? We said that a list can contain elements of similar or dissimilar data types. Now let's change one of the type of one of the elements in this list from integer to float. Let's modify the third element of the list and make it 30.5. So we have 3 integers in this list and 1 float. So let's run the cell again. You can clearly see this time also Python does not raise any error. So we have verified our second point as well. We shall verify the third and the fourth point later. Now let's verify the fifth point. It says list allows duplicate elements. So instead of giving these 4 different values, let's add another value which is same as the third value, that is 30.5. And now let's rerun the cell and let's see whether Python raises any error or not. Python does not raise any error when you initialize a list with duplicate elements, right? Now if we print the list, and you can clearly see that the list retains both the elements, the third element and the fifth element. Although the value of the third element and the fifth element are exactly same, the list retains both of them. Okay, now that we have got the basic idea about list, let's see how we can access the elements of the list one by one. We can do that by using a for loop. Remember, a list is very similar to a string. Just like in the string, we used to iterate over each and every character of the string using a for loop, we can do the same thing in list as well. The characters in the string are analogous to the individual elements in the list, and the entire list is analogous to an entire string. So let's see how we can use a for loop to iterate over the elements of a list. So let the iterator variable be I, or let it be element in li, because li is the name of our list that we declared earlier. So using this for loop, you can iterate over the elements of a list. And if we run the cell, it will print all the elements of the list one by one. Now let's say instead of iterating through all the elements, we want to access a specific element in the list. How will we do that? We will do that using the index of that specific element, just as we did in case of strings. As we all know, in programming, index always starts from 0. So the index of the first element is 0, the index of the second element is 1, the next element is 2, the index of the fourth element is 3, and so on. So that's how it looks: 0, 1, 2, 3, 4. And index can also be negative. If we consider the negative index, then negative index starts from -1. So the index of the last element of the list is -1. The index of the second last element is -2. Third last element is -3. Fourth last element is -4, and so on. So a specific element in a list has a positive index as well as a negative index. You can use either of these indexes to access that specific element. So let's see that in action. Let's flip to Jupyter Notebook. Okay, let's say we want to access the fourth element of the list. So what is the index of the fourth element of the list? The index of the fourth element is 3 and the negative index is -2. So let's access that specific element using the index. Print li 3, and let's run the cell, and you can see we get the fourth element of the list as expected. Similarly, if we print the index -2, we will get the same element. Let's try that as well. -2, and let's run the cell, and we get the same element. So that's how, using either the positive index or the negative index of the element, we can access individual elements of a list. Now instead of trying to access individual elements from a list, you may want to access multiple consecutive elements. Like you may want to access the second, third, and fourth element. Now how will you do that? For that, we have to take the help of slicing operator, just as we did in case of strings. And for slicing operator, we have to specify a start index and an end index. So if we want to extract the elements from index 1 to index 3, then we have to write it like this: li. Here we will specify the start index, that is 1, and here the end index will be 1 greater than the index of the last element that we want to access. So what is the index of the last element that we want to access? The index of the last element that we want to access is 3. So the end index that we have to specify in the slicing operator will be 1 greater than 3, that is 4. So if we run it, it will give us the desired output, that is 20, 30.5 and 40. So in case of slicing operator, the specified start index is included in the extracted sequence, but the specified end index is not included in the extracted sequence. So the extraction happens from the start index till the index which is 1 less than the specified end index. I hope you have understood this. Similarly, if we want to access these 3 elements, but this time we want to do the slicing with the negative indexes, then what will be our start and end index? Our start index will be -5 and our end index will be 1 greater than the index of the last element that we want to access. So this is the index of the last element that we want to access. So the end index that we want to specify inside the slicing operator will be 1 greater than -3. So this will be our specified end index. So inside the slicing operator, we will specify -5 to -2. Then we will get these 3 elements, right? So let's do that. This time we extract the first 3 elements of the list, -5 to -2, and if we run the cell, we get the expected output 10, 20 and 30.5, right? 10, 20 and 30.5. That's what we were trying to access. So that's how the slicing operator works. Let's discuss one more thing about the slicing operator, and that is, if we specify only the start index in the slicing operator and don't specify the end index, let's see what happens. So here we will only specify the start index and will leave the end index blank. Now if we run the cell, you can see in such cases the slicing operator will start at the start index, will start extraction at the start index and will continue till the end of the list. So if you don't specify the end index in the slicing operator, the slicing operator will start at the specified start index and will keep extracting till the last element of the list. Similarly, if you don't specify the start index and only specify the end index like this, then what will happen? Then it will start the extraction right at the beginning of the list. That is it will start extracting right from the first element of the list and will extract till the previous element of the specified last index. So here it starts extracting from index 0 and extracts till index number 2. So these are the 2 concepts related to slicing operator. If you don't specify the end index, it will keep extracting till the end of the list, and if you don't specify the start index, it will start extracting from index 0 and will keep extracting till the index which is 1 less than the specified end index. So we have discussed these 2 points as well. If the ending index is not specified, the slicing operator starts at the specified start index and retrieves all the elements till the end of the list, and likewise if only the ending index is specified, all the elements are retrieved from the beginning of the list till the index which is 1 less than the specified end index. So friends, till this point we only accessed the elements of the list. Now let's try to modify the list. So let's say we want to add an element at the end of the existing list. So let's see how we can do that. Okay, so what is our current list? Our current list contains these 5 elements, right? and we are interested in adding an element at the end of the list. So let's see how we can do that. For doing this, we have a function called append. Okay, so let's say we want to add the element 50. So the element that we are trying to add at the end of the list, we have to pass that element inside the append function. So if we run the cell, so the new element 50 has been added at the end of the list. Now if we print the list, you can see the new element 50 has been added at the end. Now let's say instead of adding the element at the end of the list, we want to insert the element at the second position of the list. That is, we want to insert it between 10 and 20. Then what will be the index of the element? The index will be 1, right? Because the index of 10 is 0. So the index of the new element that we are trying to insert, the index of that element will be 1. And all the rest of the elements will shift one place to the right to make space for the new element. So how we can do that? So there is also a function called insert which we can apply on list, and inside the insert function we have to specify the index at which we are trying to insert the new element, and as the second parameter we have to specify the element that we are trying to insert. So let's say this time we are trying to insert 60 at index number 1. So let's run the cell and it has been inserted. Now if we again print the list, you can see that the new element 60 has been inserted at index number 1. Now let's say we want to replace a certain element of the list with some other element. So how we can do that? Let's say we want to replace this element by some other element. So first we have to determine the index of this element. What is the index of this element? The index of this element is 2. So what we will do, we'll simply access this index and we'll set the value of our choice. And then if we print the list again, so this number should be replaced by 30, right? Let's run the cell. You can see the element at index 2 has been replaced by the number of our choice. So we have seen how to insert elements or how to replace elements at specific index of a list. Now we will see how to remove elements from a list. So for removing element from a list, we simply have a function called remove. So inside the remove function, you have to pass the value of the element that you want to remove from the list. Let's say we want to remove the element 40 from the list. So if you pass 40 here, and then if you print the list again, and then run the cell, you can see the element 40 has been removed from the list. Now one thing to mention here is that if you have multiple elements of same value inside the list and if you want to remove that element, so let's say we want to remove the element 30.5, okay? Now if you pass the value 30.5 and then again print the list, you can see that only the first occurrence of 30.5 has been removed. So when you use the remove function, it only removes the first occurrence of the value that you pass inside it. If the value that you pass inside the remove function has multiple occurrences in the list, it will not remove all the occurrence. Rather, it will remove only the first occurrence. So if you want to remove all the occurrences, then how will you do that? You may say that I will do that using a for loop like this. So first of all, let's initialize the list again with multiple 30.5. Currently it is containing only one 30.5. So let's initialize it again with multiple 30.5. Now if we run the cell, it is currently containing two 30.5 values. Now to remove both of these values, if we use a for loop like this, for element in li if element double equal to 30.5, then li dot remove element if we do it like this and run the cell, and then if we print the list again, you can see only one value has been removed. So why does this happen? Why, in spite of using a loop, it is not removing all the elements that are having values 30.5? Why this is happening? I will leave it up to you to find out that. If you copy this code to Spider IDE and then with the help of the debugging tools available in Spider, if you just go for the line by line execution of the code, then you can easily understand why this code is not working. But still, if you have any doubt about this, please let me know that in the comment section, and I will create a separate video explaining why this code is not removing all the occurrences of a specific value. So how we can remove all the occurrences? For that, we have to create a new list. Let the name of the new list be li underscore new, and initialize it with an empty list which will initially have no elements at all. So we will iterate over each element of the original list, and if the value is not equal to 30.5, then we will append the current value to the new list. And then after coming out of the loop, if we print the new list, and if we run the cell, it removes all the occurrences of 30.5. Now instead of having two occurrences, if the original list contained 3, 4 or any number values of 30.5, let a 30.5 be here as well. Then also if we run this code, sorry, there is an error I guess. So okay, we have missed a comma here. Now if we rerun the cell, you can see even if it had 3 occurrences, 1, 2, 3, 4, it actually 30.5 actually had 4 occurrences in the original list, but all the occurrences of 30.5 were removed in the new list. So in this way, we can remove multiple occurrences of an element from a list. Okay, apart from the remove function, there is another function called pop, with which we can remove element from a list. So in the pop function, instead of specifying the value of the element that we are trying to remove, we have to specify the index of the element. So if we are trying to remove this element, what is the index of this element in the list? The index is 2, right? as it is the third element of the list, the index of this element is 2. So if we want to remove this element using the pop function, we have to specify 2 inside the pop function. So let's see how we can do that. So we will write li dot pop 2, and if we print it, it will give us the element that we have removed. If we run the cell, you can see the element that we have removed. And now if we print the list itself, and run the cell, you can see the element 60 is no longer in the list. So that's how, using the pop function, we can remove an element from the list with the help of its index. Now, if you don't specify anything inside the pop function, by default, it will remove the last inserted element in the list. So here, what is the last element in the list? 50 is the last element of the list. So if you don't specify anything inside the pop function, let's see what it prints. So in this case, it will remove 50, that is the last element of the original list. And if we again print the original list here in this cell and run the cell, you can see the last element 50 has been removed from the list. So apart from these two functions, remove and pop, we also have a keyword called del, which does the same thing. That is, it removes or deletes an element from the list. The del keyword also uses the index of the element for deleting it from the list. So if we are trying to delete this element from the list, we can write it like this: del li, the index of this element is 1, so we will write del li1, and then if we print the list, you can see that this element has been removed from the list. For after 10, we directly get 30. So this element has been removed. We can also use the slicing operator along with the del keyword to remove multiple elements from the list. For example, if we want to remove from this element to this element, then we will take the help of slicing operator along with del keyword. So del li, what is the index of this element? This is 1, right? And what is the index of this element? This is 3. So we have, as the end index, we have to specify 1 greater than the index of the last element that we are trying to delete. So it will be del li 1 to 4, because we are trying to delete till the index 3. So the end index that we have to specify is 4. So let's again print the list and run the cell, and you can see that these 3 elements have been removed from the list. So this is how, with the help of del keyword and slicing operator, we can remove multiple elements from a list. And if we want to delete the list itself, then we will simply write del li, and then if we run the cell, the list has been deleted. Now if you try to access the variable li, you are gonna get an error. So as the list does not exist anymore, that's why it gives the name error, name li is not defined. So in this example, we deleted the list itself. But instead of deleting the list itself, if we just want to empty the list, that is, we want to remove all the elements of the list, but we don't want to delete the list, then there is a method for doing that. And this method is called clear. So first of all, let's reassign the list with its earlier values. So if we apply the clear function or clear method on the list and then print the list, you can see it removes all the elements from the list. That is, it empties the list, but it does not delete the list itself. So we have seen how to append elements to a list, how to modify elements in a list, how to delete specific elements from a list. Now we will see how to join two different lists. So let's take a list li1 and assign these values to it, and let's take another list li2 which will have some other set of values in it. Let the values be some strings a b c d e f and so on. It may have more than two elements, obviously. So if we want to join these two lists, so there are two ways to do that. The first way is to use the extend method. If you use it like this, li1 dot extend li2, all the elements of the list li2 will get appended to the elements of the list li1. So the list li1 will actually get extended. So if we print the extended list li1 and run the cell, you can see the elements of li2 have been appended at the end of li1. So this is one way to join two lists, and another way is to simply use the plus operator. If you use li1 plus li2, okay, before that let's assign the original values to these two lists, and if we just print li1 plus li2, or let's take a third variable l3 equal to, or li3 equal to li1 plus li2, and if we print li3 and run the cell, you can see we get the same result. That is, the list li1 and li2 have been joined. So in both the cases we are getting the same end result, right? But is there any difference between these two approaches? Yes, there is a subtle difference between these two approaches. In the first approach, no separate list is getting created. Rather, the first list li1 itself is getting modified or extended to accommodate the elements of li2. So this is called in-place update. That is, the list li1, the original list itself, is getting updated in place to accommodate the extra elements. But in this case, none of the original lists are getting updated. Rather, a new list is getting created which is accommodating all the elements from these two original lists. So this is not an example of an in-place update. If you print li1 and li2 here, like this, and if we rerun the cell, you can clearly see the original lists have not been modified, whereas in our previous example the original list li1 was modified. So next we are going to see how we can copy a list. So let's have a list and let the values be 10, 5, 20, 30, whatever. Okay, so if you, and instead of giving li, let's give it a name li1. Now if we take another variable li2 And if we do it like this, li2 equal to li1, then if we print both the variables li1 and li2, and run the cell, then obviously we can see that both the list variables are printing the same value. But here what is actually happening is that both the variables li1 and li2, it's li1 actually, so both these variables li1 and li2 are actually pointing to the same memory location, right? If you are not familiar with this concept, I would recommend you to first watch my video related to memory management of variables. In that video, this concept has been discussed in detail. The link of that video has been given in the description section. So from that video, you can clearly understand when we do it like this, both the variables point to the same memory location. As both the variables are pointing to the same memory location, so any changes made using li1 will also be reflected in li2, right? So let's verify that. So let's say we make a change in li1. Let's say we append a value to the list li1. Let's append the value 50, and then if we print li2, let's print both of them, li1 and then li2. And if we run the cell, you can see the change made in variable li1 is also getting reflected in the variable li2, which may be undesired at times. You may not want to change the variable li2 at all, but if you copy the list like this using the references of those two lists, then any changes made to a particular variable will automatically get reflected in the other variable as well. To avoid this, we have a method called copy in Python, which allows us to make an actual copy of the original list instead of just copying the memory addresses. So let's see how we can do that. So in this case, we will do li2 equal to li1 dot copy, and then if we make a change in li1, let's add an element 60 to it, and then if we print both li1 and li2, so only the element 60 will be added to the first list, but that change will not be reflected in the second list, that is li2. So let's run the cell, and you can see the element 60 has only been appended to the first list. Any change has not been made to the list li2. Now let's see at back of the scenes what is actually happening. So here what is happening is that li1 was pointing to this memory address, to this list. Now when you do li1.copy, what is actually happening is that a new object is getting created at a new memory location, and li2, instead of pointing to the same memory location, li2 is pointing to the newly created object, and all the values from the original object gets copied to the newly created list object. That's why if you make any change in this object, li2 does not get affected, because you are making the change in this memory location, which does not have any relation to this object or this memory location where li2 is pointing. So in this way you can make an actual copy of the original list. So friends, in the last few examples, we added items to a list we deleted items from a list, we replaced specific elements in a list and did all kind of modifications. So from the last few examples, we can easily say that a list can be modified. So we have also verified our third point as well, that is a list is mutable. Mutable just means the whether an object is modifiable or not. If the object is modifiable, then we call it mutable, otherwise we call it immutable. So from our previous discussion, we can easily say that a list is obviously mutable. And now what is the third point? The third point is that a list maintains the order in which items are inserted in it. And we also have seen examples in which the item that we appended to a list was appearing right at the end of the list. So this point has also been verified. Okay, let's verify this point again. Let's take this list only. And let's add some items to this list in this order. First we add, let's say 10 again. Then we again add 80. Then let's say we add a string. Let the string be ABC. So according to our argument, the order in which we have added the items in the list, first of all, the items that we are just appending to the list should appear right at the end of the list, and the order in which we are appending the items to the list, the order should also be sustained. So let's see whether that actually happens or not. If we run the cell, you can see that we added 10, 80 and ABC recently, and these items are actually appearing at the end of the list. And the order in which we added the items, first we added 10, then 80 and then ABC, and the items are appearing exactly in the same order. First 10 is appearing, then 80 is appearing, and the last item that is appearing is ABC. So the fifth point is also verified, that the list maintains the order in which the items are inserted in it. Okay. Now let's see a method or a function with which we can identify the number of elements in a list, that is the length of a list, and the function name of the function is len. If you print len li, it will give you the number of elements present in the list, and it's 9. 9 elements are present in this list, so it gives us 9. There is another method called sort, with which you can sort the list in ascending order. So let's first take a list which only contains numeric elements. Let's take this list only. And if we apply the sort method on this list and then print the list, it will sort the elements in the list in ascending order. And you can see the elements have been sorted in ascending order. And this is also an example of in-place update. Look at this, the original list itself is getting updated. Any new list is not getting created. Had any new list got created, then we would have to store that new list in another variable like li_new. Now, if we try that out in this example, and if you print this li_new and run the cell, you can see it's giving none. Why is it giving none? Because the sort method does not create any new list, rather it applies the sorting on the original list itself. As this method is not returning any new list, that's why the newly created variable li underscore new is not pointing to any memory location. That's why it is giving none. Okay, the next method that we are gonna discuss is the reverse method. Using the reverse method, you can reverse a list. So let's print the value of the list currently. So currently our list contains these values. Now if we want to reverse the list, we will simply use the reverse method on this list. And then if we again print the list, you can see the list has been reversed. And this reverse method also does an in-place update of the list. That is, it updates the original list and does not create any new list. Now, if you want to count the number of occurrences of a specific element in a list, then you have to use the count method. Suppose you want to count the number of occurrences of the element 10 in this list. So, how many times 10 occurs in this list? 10 occurs twice in this list, once here and once here. So if you apply the count method on this list and then pass 10 inside it and then print it, then it will give you 2, because the element 10 is appearing twice in the list. Similarly, you can determine the number of occurrences of any specific element in the list. Last method that we are going to discuss is the index method. This method gives you the index of the first occurrence of a specific element in the list. So let's see what it actually gives us. Let's say we want to know the position or the index of the element 10 in this list. So first let's assign this value to the list, and in this list we want to know the index of the element 10. Now for that, if you write it like this, li.index10, and run the cell, it will give you 0. Why does it give you 0? The element 10 appears twice in the list, at index 0 and at index 5. But as I have just mentioned, the index method only gives you the index of the first occurrence of an element in the list. So which is the first occurrence of the element 10 in this list? This is the first occurrence, and the index of this position is 0. That's why the index method gives you 0. Now if you want to know the index of this element, just simply change the argument inside the index method and run the cell. It will give you 2, because the index of the element 50 is 2 in this list. Similarly, the index of the element 20 is 4, right? So any element, if you are passing an element in the index method which appears more than once in the list, it will only give you the index of the first occurrence of that element. So friends, that's it for this video. I have given you some exercise problems. Please try to solve these problems, and you can let me know the answer of the first 3 problems in the comment section. And if you face any problem or difficulty while solving any of these problems, then you can let me know that in the comment section, and I will come up with the solution of that problem. If you have liked my video, please subscribe to my channel so that you get notified when I will upload more Python and data science related videos. And please don't forget to like and share my video so that it reaches a larger audience and they also get benefited from it. Thanks a lot for watching.